Well, tithe, time, and formation wait for no man. And that will kill me here, so it's time to start. Well, good afternoon, everyone. We hope you're enjoying day one of the Sea Air Space Symposium thus far. I'm Jesse Wilson, the Naval Surface Customer Account Lead for Raytheon RTX here in Washington, D.C. Before joining the company, I served in the U.S. Navy for 33 years as a surface warfare officer. RTX is a proud four-star sponsor at Sea Air Space, and we are delighted to sponsor the Speed to Fleet panel. We hope you have a chance to stop by the RTX booth, where you can see technology from all three of our businesses: Collins Aerospace, Pratt & Whitney, and Raytheon. There you can also pick up a ships and subs of the U.S. Navy poster and celebrate Pratt & Whitney's 100th anniversary tomorrow night at the reception. And a little secret, there's a signature cocktail associated with that. You won't want to miss that. RTX is the world's largest aerospace and defense company. With more than 185,000 global employees, we push the limits of technology and science to redefine how we connect and protect our world. At RTX, we know that many of our customers, the products we produce, are more important than ever, and the global demand is growing dramatically. That's why we chose this topic. We share the Navy's desire to streamline how we work together to get capability in the hands of the warfighter in the fastest and most affordable way possible. And without further delay, I'd like to introduce our moderator. And I'd also like to say a dear friend, Megan Eckstein. Megan is the Strategic Communications Action Officer for Strategic Insight in Arlington. She's also the owner of Mayday Communications. Many of us know her best from her years as a leading defense industry journalist and her time as the Naval Warfare Reporter for Defense News. Many of you received some very hard questions from her from time to time. Megan covered military news for over a decade with a focus on U.S. Navy and Marine Corps operations, acquisition programs and budgets, and has reported from 4 geographic fleets across the globe. Megan, thank you for your service. Thank you for your support. Over to you.
Great, Admiral. Thank you so much for the kind introduction. I'm very excited to be moderating this panel today. I think hopefully everyone's had a good morning here at Sea Air Space. You've probably already heard quite a bit about the Maritime Industrial Base and the need for close partnership between the sea services and that industrial base. So I think we're going to get into some really interesting topics here. So speed to the fleet, how defense industry can move faster, innovate, and scale to meet customer needs. And I can't think of a better panel to discuss those topics. So thank you to the Navy League for hosting us, and thank you again to Raytheon for sponsoring this discussion. I'm going to go ahead and introduce our panelists one by one. We're going to have a couple questions up here, but I'm really looking forward to audience Q&A, so please get your questions ready. And when the time comes, we have a microphone over here on the side of the room. So just to set the scene, when we talk about speed to the fleet, it's not just getting new gadgets out quickly. It's about getting capabilities out at scale with a wholeness that includes spares, training, valid concepts of operations, and more. It starts with the requirements, it goes through program planning, and it continues past fielding into sustainment and modernization. In short, the goal is innovation and capabilities with quality and quantity. So with that in mind, I would like to start in the middle here. I have Ms. Barbara Borgonovi, the president of Naval Power at Raytheon. She specializes in integrated air and missile defenses, advanced sensors, space systems, hypersonics, and effectors. Previously, Barbara led corporate strategy and development for RTX. She joined the company in 2001 and has held positions in program management, supply chain, operations management, and quality engineering. She holds a bachelor's degree in mechanical engineering from California Polytechnic State University, San Luis Obispo, and a master's degree in business administration from Pepperdine University. And Barbara, if you'd like to kick us off, on this issue of scale, the Navy has acknowledged its industrial base is struggling to ramp up production on a range of weapons systems, and it created a weapons industrial base funding line to help create additional suppliers, tackle bottlenecks that hamper production and fielding at scale. Raytheon has both received this funding and also invested its own money to grow the supply chain. How are these efforts going so far to increase output, and what specific improvements can you point to?
All right, thanks, Megan. Probably speaking first on behalf of all the industry here today, I'd say there's no bigger calling right now than supporting the Navy and the need not just for increased demand, but also the change in the fight, going from a permissive environment to really what Admiral Kilby talked about this morning, sea control. So we know our role. We very much understand the key role across the industry that we play in supporting that. At Raytheon, our focus is on increasing capacity, especially in our effectors in the missile side of our house. And we've been making quite a bit of investments. We put in $115 million into our integration facility in Huntsville, Alabama, for example. And a lot of our improvements on capacity, when you think about what we do, is the facility, the assembly side, but also the test. Test capacity tends to be one of our key constraint areas, and we're moving to automated test cells that enable us to do environmental test controls in parallel with the test points just to get more capacity out. But what really is our true constraint is, our supply chain. And we've seen, and I'm sure many of you have, a lot of challenges over the past 5 years, especially as we worked our way through the pandemic. Lots of improvement in areas, but still some real acute challenges for us in the supply chain. For us, I'd say the biggest challenge on the effector side has been rocket motors and the availability of rocket motors to support our missile production. We have deployed individuals to our suppliers. I'll use Aerojet. They're only one supplier as an example. And we have seen improvements at the start of 2025 in performance. So we really appreciate the partnership that we're getting from Aerojet and the business there. But we have to think ahead, because when we look at the demand and capacity needs, it's not just about shoring up one piece of our supply chain. We need to be looking ahead and ensuring that we have the scale that is truly needed to meet the demands of today's Navy. And that's why it requires us to look at additional sourcing. We announced today that we're looking at additional sources of supply on rocket motors with NAMO, with Avio, but we also have our partner here to the left with Ursa Major, where they're bringing new technology, new processes, which I'm sure Ben will talk about as well, to board that we can tap into. The two things I would say about the supply chain, number one, it takes all of us, and it takes more than just a demand signal. A lot of times industry comes in and says, we need to know what the demand is. We know what the demand is. Of course, we need to know that that demand is sustainable to support bringing on additional sources, and that's the right decision. But we really do know what our demand signal is. But we have to go into deep levels of our supply chain, not just our next tier, down into multiple tiers of our supply chain to address that speed to the fleet and the scale that is needed. And the second piece is it really takes an ongoing engagement. It takes all of us. So Megan, how is it going? I would say it's, anybody, if I stood up here and said it's done, it is not done. We're on a journey to ensure that we can meet the needs. We have seen improvements as we work our way into 2025. We know what our North Stars are by program. We track it at a detailed level, and we'll see increased capacity across our missile effectors, whether that's a Standard missile, an AIM-9X, a Tomahawk. We know what those priorities are, and we are seeing successes to get to them.
Fantastic. Next, I'm going to move to the far end of the table. We have Mr. Ben Nicholson, the Chief Growth Officer at Ursa Major. Ben started in this position last August. He has worked in Washington, D.C. for 25 years and has extensive experience in U.S. government operations, programs, and contracting. He specializes in federal appropriations process for national defense, aerospace, security, and intelligence programs. This includes time both as a U.S. Coast Guard officer as well as a Hill staffer focused on Homeland Security appropriations. He holds a BS in Naval Architecture and Marine Engineering from the U.S. Coast Guard Academy and a Master's of Science in Naval Architecture and Marine Engineering and Resource Policy and Behavior from University of Michigan at Ann Arbor. So Ben, you are working many of the same issues that Barbara is. I wondered if you could discuss how companies like yours can support speed to the warfighter and accelerating production scale by providing alternate supply bases, and how do you do this alongside traditional companies rather than being pitted against them?
Well, thank you very much for the question. And first of all, thank you for having me. And right now, to all the service members that are out there standing watch, thank you. As someone who worked for the tip of the spear, the U.S. Coast Guard, grateful for all those who are in harm's way. Never want to forget who you're working for. When we talk about speed to the fleet, at Ursa Major, we are looking at propulsion problems, as Barbara rightly said, and we're trying to take a very innovative approach. And speed is certainly a foundation of everything that we do. It's a core value of everything at Ursa Major. And in fact, we've taken clean sheet designs and gone to hot fire in 29 days because we're able to use the state-of-the-art manufacturing processes to get there. So when we look at solid rocket motors, hypersonics, and in-space propulsion and that problem set, more often than not, propulsion has been the proverbial long pole in the tent. And it's been very hard to solve hard technological problems and supply chain problems, as Barbara rightly said. So Ursa Major's whole ethos has been to attack that problem and attack it fast. Now, when we talk about speed, it's only one element of kind of the old rubric of defense contracting, right? Good, fast, and cheap. And for years, you could say to yourselves, well, you can only get two of those three. The current threat environment, the speed at which our adversaries are advancing, the demands of our men and women in uniform are changing that paradigm. We've got to figure out a way to sufficiently attack all three. So we were just at a Project Convergence, flew with our partners in Raytheon, and we flew a solid rocket motor that had been designed, built, and flown multiple times successfully in less than a year. And we did that on an autonomous launcher developed by Raytheon with other partners, Oshkosh and Forterra. And that could only be done through partnership. So when we talk about innovation and agile manufacturing, that's one way to attack it. But the real secret sauce here is working together and through all kinds of collaboration. And what I see as one way to attack this problem is it's not a startup, it's not a prime, it's taking that combination, right? Their scale, their skill, their heritage, all of that combined with our innovation and speed, that's how we solve hard problems to the fleet. And quite frankly, they're demanding it and honestly deserve it. It was Wyatt Earp who said, speed is fine, but accuracy is final. And you got to learn to be slow, but in a hurry. And yeah, I just quoted Wyatt Earp. The thing that I think he was saying, and I like to call it deliberate speed, right? We can move fast, right? But it's speed, at scale, and performance. And we've got to figure out a way to do all three. So when we look at additive manufacturing, what that brings to the table, why would you print all of these materials in a solid rocket motor? Well, it gives you complexity essentially for free. You can iterate on the design, and you can do that very, very fast, and you can lock that in and save that time and money up front. So then we're ready to scale with something that we know will work and work better and bring different technologies to bear. Quite honestly, at Ursa Major, we think very often about those on the front line, and it's something that we feel a calling to do, and I think Barbara used that word rightly so. So thank you very much.
Thank you so much. Before I move on to the general, there are plenty of seats up here in the front row for all the folks that are standing around the side. So if anyone wants to come find a seat, you are certainly welcome to. So right next to me, I have Brigadier General David Walsh, who I'm very pleased to have on another panel alongside me. He is the Program Executive Officer for Air ASW, Assault, and Special Mission Programs at the United States Marine Corps, working at NAVAIR now. He was commissioned into the Marine Corps in August of 1992 after graduating from University of Virginia. He reported to Naval Air Station Pensacola for flight training and was designated a naval aviator in February 1995. He has since served as an AH-1W pilot and an H-1 test pilot. He was then selected as the first cadre of Marine Corps acquisition officers and has continued to support the H-1 community and the Marine Corps aviation broadly ever since. In March 2021, he was selected as the military assistant to the Assistant Secretary of the Navy for Research, Development, and Acquisition. He was then appointed as Program Executive Officer for Land Systems in February 2022. And he, in June of 2024, assumed duties as Program Executive Officer for Anti-Air Submarine Warfare, Assault, and Special Mission Programs. So General, your portfolio includes some very well-established workhorse programs, such as your H-1, the MH-60, V-22, P-8A, C-130, as well as in production CH-53K and the upcoming TACAMO E-130J. Speed to fleet can mean a number of different things to these programs based on where they are in their program life cycle. So how are you ensuring that you're putting the most capable aircraft out each day with speed and urgency in mind?
Thanks, Megan. First of all, thanks for the opportunity to be here to talk to everybody. I know we've got a lot of acquisition professionals, industry executives out there, a lot of folks who are smart on this process and have lots of great ideas on how to make the acquisition process faster. So I really look forward to the conversation. And thanks for our industry partners for being here. Thanks for our fleet customers for being here and joining this conversation as well. Like Megan mentioned, we've talked about this. This is probably our third or fourth panel together talking about the same subject. So really enjoy talking about it. I like hearing all the ideas and doing what we can in the acquisition world to try and get folks, get stuff out to our warfighters more quickly. So you asked about how we balance, how we make sure we get speed to the fleet and getting the most capable out there equipment out there as quickly as possible. So I think speed and most capable are kind of subjective and different depending on where you are in the life cycle and the context that we're talking about. Where we are right now today, and what the fleet needs to do right now is maintain that enduring presence to deter conflict in the competition phase right now, be ready to respond around the world to anything that comes up as an emergent crisis, and then we need to build capability so we can fight and win decisively if we do get into conflict. And you've heard about that all day this morning. What that means to us in the programs right now in the competition phase around the globe is shoring up our readiness by working with the industry partners to build our defense industrial base, looking around the globe with our allies and partners as well, take advantage of all of those opportunities around the world, particularly in the theaters where we think we're going to be operating most in the next few years. Optimizing our supply chains, making sure those parts get from our industry partners to the flight line, in our case for the aviation side, to the flight line, so those Marines and sailors can put them on the aircraft and go do the missions they need to do. We need to build agility and responsiveness in that defense industrial base and in that supply chain so those parts can get there quickly. And as demand changes based on what we're learning, especially on the new aircraft, that the defense industrial base and supply chain can adjust to meet those new demands. And then as we look more towards the future, be able to quickly develop and deliver incremental capability upgrades for the platforms we have in service right now, and then building towards those big jumps and managing that transition to those new platforms like 53K and EC-130J. So as we look forward to that future fight, maintaining what we're doing right now, looking to that future fight, there's a few things that we need to do that we're investing in, key capabilities where they're industry partners right now, such as sensors, make sure we have the most advanced sensors on our aircraft, making sure our platforms are able to accept those new capabilities by bringing MOSA and open system architectures to our platforms, bringing new munitions on board so we can build that kill chain from sensing, sharing that information, and then completing the kill chain either kinetically or non-kinetically to defeat an enemy. Using AI to help us make better decisions, whether it's at the tactical level, through the acquisition system, in our supply chain and sustainment, making sure we get the right parts, that we buy the right parts, build the right parts, and deliver the right parts where they're needed. And then managing those transitions between the legacy platforms and the new emerging capabilities without degrading capability and readiness as we make those transitions. Some of the things that we're doing in the acquisition world and POA in particular to ensure we're accelerating, bringing that speed while we're balancing and accepting risk at the right level. And it's all about that balance, making well-informed risks at the right level, trading off cost, schedule, performance to make sure that the fleet ultimately gets to make those decisions and balance what we need. We talked a little bit about deliberate speed at scale. If we're going to push capabilities out more quickly, the acquisition system needs to be able to take some risk, Industry needs to be able to take some risk. The fleet needs to be able to make those smart trade-offs to make sure we get the right capability out there, a min-viable capability as quickly as possible, then quickly iterate and build on that to bring the final capability that we need out there. I think the most important thing we can do in the acquisition world is change the culture. We need to be able to be comfortable with taking that risk. We need to move away from the risk-averse culture, and get away from avoiding or eliminating risk and balancing and taking smart risks. That takes collaboration. That's not just the government side that's talking with our industry partners, making sure they are comfortable taking risk. They enable us to take those smart risks. They take financial risk with us that we can trade and balance. And then, again, bring it to those fully informed trades. And that takes a lot of collaboration, a lot of trust, a lot of yes-if conversations. Vice, you can't do it that way, which is what we've had sometimes in the past, either from the industry side, the fleet side, or the acquisition side. So that's what we're working on right now in PEOA, focusing on the mission, focusing on outcomes, and focusing on the warfighter.
That's a great way to kick this off. I want to go back to the yes-if conversations notion. Obviously, culture is a piece of that, and we will get back to that later in this discussion. But in terms of enabling those yes-if conversations between government and industry, are there any processes that the Navy and Marine Corps could take another look at, change, modify, to allow for those types of conversations to develop, buy, and field new capabilities faster? And similarly, is there anything industry can be doing to help facilitate those conversations and move faster?
Yeah, I think that's got to be a collaborative conversation. Industry, government working together across the life cycle, starting with requirements all the way through resourcing, development, production, and into fielding and sustainment. On the requirements side, I'll just start from the front. On the requirements side, I think we need to resist the temptation to buy small numbers of exquisite platforms and be able to make those smart trades on requirements to kind of tilt towards speed versus those exquisite platforms. And I know, our Marines, our sailors deserve the very best, the absolute best we can deliver for them. But if they get one of some exquisite platform 10 years from now, it doesn't do them any good. So we got to have that smart conversation about requirements and resist the urge to demand that big bang delivery of everything up front. So specifying a min-viable capability, working with industry iteratively, quickly, to make sure that we understand the art of possible and what we can do with the resources and the time we have available to deliver the best we can for our Marines and our sailors as quickly as possible, and then iterate on it. On the resourcing side, as we plan our budget and work towards getting the money aligned in the right place, there's the PPE reform proposals that are out there. I think those would be great. I think what we can do with what we have right now is think about how we fund capabilities vice items. So instead of buying a ship or an airplane, let's think about the capability that brings, put money into the budget that aligns with those capabilities, and let industry and the acquisition world find the right technical solution to meet that capability requirement. And last point on resourcing, effectiveness over efficiency. We've had a lot of talk about it if you've been listening to conversations over the last few months about budgeting and all of that. Effectiveness over efficiency. We've prioritized efficiency for our program managers over the last, as long as I've been doing this, a couple of decades, and with a strong incentive for them to spend money because it's going to expire, and all those types of conversations we have as program managers and as budgeteers. That, given a little bit more flexibility in the budget process and in the budget construct, we could probably make better decisions about how we're spending our money, again, with the outcome focus of bringing that capability to our Marines and sailors as quickly as possible. Not necessarily the lowest cost, but the best value for every dollar that's spent. I'll go through a couple of quick other things. Contracts, getting the right contract types, working in the industry to share risk, supply chain risk, technical risk. Through the contract, we can do better at that, both industry and the government side. We can use modeling and simulation, digital engineering environments in the development phase, and all the way through testing to satisfy test points more quickly, more iteratively, instead of setting an aircraft up to fly every test point. In the production world, we need to look at how we qualify things, how we, the weapon system explosive review board that we serve, some of our shipboard requirements. We need to think about how we qualify our industry partners and our equipment to meet those production requirements. understanding how we feel things, if we make decisions, smart decisions about what the maturity of the training and the sustainment system needs to be before we field something. That's always a tough conversation when we put new aircraft out there. When's the right time for the first deployment? Do we wait till we have a fully mature sustainment system and everybody's trained up, or do we take a little bit of risk, get it out there sooner, and then build and mature the sustainment system? And then once it's in sustainment, in operation, expanded defense industrial base, looking for all the opportunities we can between organic and industry to balance our sustainment system, leveraging our allies and partners, leveraging everything an industry can bring to us, and then being willing to make those trades maybe towards a more commercial model. We tend to look for organic sustainment in our aircraft and lean that way for all the right reasons, but there's trade-offs to be made there. If we want to go faster and we want industry to bring a more commercial model, there's some trades we have to make with the data we may need for organic sustainment to get it out there quickly and incentivize industry to bring us a product that we can field quickly. And again, that all comes back to culture, risk acceptance, risk conversations, and close collaboration.
Thank you so much. Ben, I know you at Ursa Major have a particular interest in some of those items, including the qualification process and the testing process. Could you discuss how you're looking at some of those issues and how they can be barriers to scale for you and how you're hoping to overcome some of those challenges?
Thank you for that. I mean, it's very easy to sit in this room and say, oh, they got a better idea. We have a better way to design something. It's another thing to deploy that to the fleet, right? It's got to be safe, but it's got to perform. And Barbara and I have talked a lot about qualification, finding that balance. And that's certainly an area we can attack. And I know that many folks within the Pentagon and many folks on the Hill are looking at this. From Ursa Major's point of view, we talked about bringing that design quicker to the warfighter to evaluate faster. So that saves some time. And then I think asking folks to look a lens of qualification, and I don't want to take Barbara's line, but we talked about this recently about, all right, is it safe and is the performance sufficient, and trying to find that balance point. I talked about fast, good, and cheap earlier, and I think that's an old paradigm. It's still applicable today, but I'm touched by what the general said, because when you look at the spectrum between exquisite and expensive and cost to kill ratio and cheap mass, what we're really after is precision mass that's cost effective. And I appreciate that the general went into that, because obviously cutting edge technology is not inexpensive, and it's something we are trying to develop as quickly as possible at a reasonable cost. So then when you get to qualification, you hit that proverbial valley of death. And for companies like ours that are privately funded, and we're 250 strong, but mighty and growing, you do run into this very long, laborious process that's uninterrupted by progress. And I do ask that we look at this through a lens of, all right, we've got to be safe. We're not going to put our sailors, soldiers, coasties, et cetera, Marines in harm's way, right? It's got to be safe. Understand that. But what type of sufficiency can we look at? Where are those trade-offs? And can we look at those lenses a little differently? And I'll defer to Barbara because it's really her line. But say one other point on this. When we deploy something or test something, we often look at it as through a lens of success and failure, and there are obviously degrees of that. And one of the things we take very seriously is learning from every step and iterating very, very quickly. We now have access to more data than ever. We've talked about AI and these other tools. There really aren't any failures, right? It's all how you look at it and making sure that we can iterate very, very quickly and then turning that around. And that's certainly a hallmark at Ursa Major. Thank you very much.
Megan, can I add?
Yep.
Yeah, I think whether it's qualification or anything else in this discussion, and thank you for the list, General, it's about being willing to change. And that's number one for we all have to be willing to drive change if we're really going to get the speed to the fleet. And, Ben talked about qualification. We measure for a lot of our Raytheon products that qualification, even at a sub-tier level, typically in years, because that's a process that we have done before. But even though that's a process we've done before, we now have different modeling capabilities, digital engineering capabilities. So we should be able to change that process with acceptable risk. And then Ben, I really liked what you said, because I do think that we too often want assured success in a test event versus it being part of the process of developing a product to the need and focusing on the mission. And it's a learning point that then once we iterate, we will get it right. But we have to be willing to accept some level of risk, and we can say that's, the Navy, acquisition, industry, deep into our supply base, We all have to truly say we're willing to change, not just talk about it, but take action to change.
Thank you. You mentioned increases in sort of the modeling and simulation capability. There are other, obviously, technological changes, AI, automation, cutting edge design, and fabrication tools that can bring capability to the customer faster. I'd like to start with the two industry partners. How are you looking at those technologies and incorporating them into how you do business? And how are you managing any risks that come with leveraging those new technologies?
Yeah, do you want to start that?
Sure. So we talk a lot about additive manufacturing, so printing. Some of our rocket engines are as much as 80% printed, and I had no idea that we could even print the type of bespoke alloys that can withstand 5,000 degrees Fahrenheit and thousands of RPMs. And the Air Force is an example that thinks so highly of that they'll cut it in half and then inspect it and take a long time to do it, which would you appreciate, right? It's got to be safe. So one of the things we employ is the latest in AI to inspect those materials to make sure they meet the spec. That has saved countless days of inspections, and what we have shown is that applying those tools to an advanced manufacturing process just helps you iterate faster. And so, again, iterate faster, apply those tools. That paradigm is uncomfortable for some people, right? Is that good enough, right? And we go back to what Barbara said, measuring it in years. I think we're finding, because I mean, how many times do you have to inspect it before it's okay, ready to go? And we've proven that, okay, we can print something that is just as good as a cast and weld system that takes, tooling and die sets, and it's an ancient way of doing things. So that's just one example.
Yeah, and at Raytheon, and we obviously have a lot of digital design activities deployed. We're also focused on developing composable architecture. So that allows us to then have building blocks, whether that's in our radars, like our SPY-6 radar family, or in our effectors, where then we can take the pieces and put them together at a faster speed to get the development cycle done. I would say from an AI perspective, there is so much more, and I'm sure others in the audience would agree with me, that there's so much more capability that we could deploy from an AI standpoint, but we have to be willing to accept the deployment into our products and into the fleet. But there's pretty much endless opportunities. We're very focused on AI deployment within our internal processes at Raytheon, so we're using it from procurement to inspection activities, but also then looking at how we can insert it into our product development as well.
For digital engineering, I'll start, at the design phase. Digital engineering, E130J is using a digital engineering environment with their industry partner to allow them to hopefully garner all the benefits of that digital environment for open system architecture, for future capability development, and for sustainment. So we're kind of at the beginning of that journey with them. It helped us as we went through the source selection process, and we're into design now. So we're kind of leading the charge on that from E130J. As you start using AI and that data that's developed into design, into qualification, and into sustainment, there's a ton of applications, whether it's on the business side, and we're looking at developing the right procedurals, the right data we need, the right contract types, all of the ways we can use AI just to help us, again, make smart decisions about how we buy our equipment. In sustainment, using it to understand demand patterns, understand where we need to buy parts, where we need to position parts to make sure that they're for our aircraft on the flight line. Condition-based maintenance, so we can forecast when parts are going to be needed and when they're going to need to come off the aircraft, so we can keep them on the aircraft longer, and again, build that readiness, build that availability. And then I think all of it comes down to understanding and learning about it, helping our government engineering teams and sustainment teams learn and build confidence and be able to make those smart risk assessments. And again, never compromising safety, because we're never going to put our Marines or sailors in something that is unsafe, but making sure we get the best of the data we have available for us.
Back to the culture piece you mentioned before. I mean, are you seeing a willingness on your team to, say, invest more in spare parts when an AI system is telling you ought to, or is there, some concern relying on those tools just yet?
I think we're leaning into it. I think Admiral Chevy and the team at NavAir has done a really good job of trying to push forward with our engineering sustainment teams to use that data for sustainment, working with NavSup and our partners on the supply side to make those smart buys. You're talking about risk, right? You're, in that case, talking about financial risk. Are you going to put extra parts on the shelf that you may not need because AI got it wrong. That's a financial risk that we need to be able to take smartly in order to move forward and make the best of that data. And then on the engineering side, again, we're talking about satisfying test points with digital engineering and the data we get from those digital models. That's a risk, right? We should be taking a smart risk, but that is a risk that traditionally the Navier community, the Navier engineering community has not taken, but we're leaning forward.
Good. Ben and Barbara, you both are obviously at very different sized companies, but I wondered if you could talk about just organization culture and how you can get that culture to be more innovative, deliver faster, manage risk in this way. What are some of the characteristics that you're looking for as you try to change your company's culture?
Yeah, well, I'll start then, and then I'll tee it off to you. I think, number one, it always starts with leadership, right? So leadership is going to define the culture of an organization, and it's my role as the president of my business to define that culture. I think first and foremost, it's ensuring that our teams can come with us with bad news, right? If you're going to be innovative, it does mean that there's going to be risk of failure. And if I shoot the team that comes in that says we had a failure, they're probably not going to lean in and want to take further risk. So I think, how we respond, how we instill trust in the team, and then, ensuring that we can do both at once. Right now at Raytheon, I have very acute challenges that I have to solve for the Navy. But I need to be able to do that while simultaneously also driving the big ideas, the future forward-looking activities that may not be done tomorrow, and encouraging my team to think about innovation, both in how we solve our acute challenges that may be tomorrow focused, but then how do we solve the longer range strategic needs of the organization and the mission needs of our customer. And again, I think that comes with how we set the tone with trust and feedback to the organization at the top.
Well, I completely agree with leadership. Obviously, we're at the other end of the spectrum from a company that's as established as RTX. We came at this we have a lot of refugees from SpaceX, Blue Origin, myself from L3 and Honeywell, and we've come together in this company where we have an open dog policy. You got to like dogs at Ursa Major. We got a lot of dogs, and they're very good engineers if you feed them. But in all seriousness, when we look at our culture, it's a little bit different, right? We can iterate like nobody's business, and we've got some brilliant engineers, and they will iterate as a day is long. But you got to keep them grounded in meeting schedule and needs, and then trying to scale. And that's exactly what we've done in Ursa. So we took a culture that is incredibly oriented towards speed and innovation, and very world-class engineers. Serious engineers that can work their TI-85 and slide rules. But the thing that we've tried to do now is position some leaders in place. I'm the fourth oldest person in our company. I'm 51, okay? And I feel like a gray beard every day. And I try very hard not to say, well, this is the way it was done at L3 or Honeywell or wherever else I've worked, or in the Coast Guard or on the Hill, whatever. The point I'm making here is we try to combine that innovative spirit with a little bit of experience. First strategic hire of my new CEO was to bring in the chief safety officer who we stole from the Navy after he retired. And that was all about scaling without blowing ourselves up, quite honestly, and making sure that we're delivering not innovative solutions, but innovative, safe solutions. So we've tried to take our culture, keep that creativity, but now scale and professionalize it. And more dogs.
And Megan, I just want to add, there's so much discussion. I get asked the question so often, it might come from one of the audience members next, about disruptors in the A&D industry right now. This is where, our view is, we need both, right? We need the help. When we meet with Ben's team, we learn a lot. And it helps us as well with how we think about our culture and our deployment. So it's a great partnership to have that in the ecosystem right now as well.
Can
I just underscore that point too? I just thank you for that, because I just want to say disruption is kind of a negative word, and I understand that that's a cool tech word right now, and I should embrace it. But it is all about partnership amongst all three of us. And one thing I like to point out is that the Navy doesn't produce anything but sailors, good sailors. Marines doesn't produce anything but Marines. So it's up to us, but we care very much about partnering. Disruption inherently is a negative term, so collaboration is a much better term. Thank you for that.
General, go ahead.
Yeah, I think on the government side, we've got to be comfortable with the fail-fast mentality as well, and not panic and move money and pull money from programs because they've had a test failure. And that's, again, collaboration, communication, leadership from the top all the way down, understanding the risk that we're taking, safe risk that we're taking as we move forward. And when we see a failure, not resisting the temptation to defund the program or slide the program or do anything like that.
General, you've had some interesting positions in the past several years in the acquisition community, seeing sort of the Marine Corps and the Navy side, the aviation and the ground acquisition side. And I just wondered if you've seen any trends in terms of culture on innovation and risk acceptance.
I'll say that there's a little bit different because I think partially because of the scale and the types of programs that Navy, NavAir is procuring, Navy, I'll say naval aviation versus Marine Corps and the Marine Corps Systems Command. And I think it's changing a little bit and they're probably getting a little bit closer together. But you tend to have smaller, more innovative, faster moving programs on the Marine Corps ground side, you know, with some exceptions. Aviation, you're generally buying, at least in the POA portfolio, big aircraft, big things, right? I don't know that's the right, I think, like I said, I think we're both migrating towards the center a little bit, but I don't know that's the right mix because I think for aviation, the platform isn't really the thing. The platform's part of it, but it's really the stuff the platform's carrying, the capabilities the platform enables, and we can iterate faster and be quicker on those capabilities that fly on the platform. Big aircraft, hard to iterate quickly on, necessarily the big platform, but the stuff that's in it that enables capabilities, absolutely.
Great. Audience, I hope you guys have some questions prepared. I'll turn it over to you shortly. One last one I wanted to ask before we open up to the audience. There's significant demand for both new capability and more capacity today due to both operations in the Red Sea and preparations for a South China Sea Indo-PACOM type of scenario. Has that operational reality changed anything for the government and industry ability or willingness to move faster and make any requisite changes or reforms or investments? Barbara, if you want to start.
Yeah, I'll start. So I would say, first off, yes, because that's why we continue to see the increased need to drive more capacity into our production facilities and into our suppliers. I'm very appreciative of the support we've received to get our data back from the performance. From a Raytheon standpoint, what I can say in this forum is our products are performing well, and we have the ability to receive direct feedback on specific performance parameters. And that is helping us determine what are the things we can do to support the Navy with, updates quickly. And I think that has gone really well in terms of showing the change in our ability and speed to share performance data and to take action off of that performance data. But it all comes down to, with more, again, I'll go to the effector side of the business, more firings, more need. We have got to fulfill the need to get those missiles into the hands of our sailors.
Yeah, on the government side, I would say yes, absolutely. I think the imperative that's facing us out there in the next few years with a peer adversary out there has agitated the system in a good way. So now we're talking about effectiveness over efficiency. We're talking about affordable mass. We're working with the industry over problem statements by specs and having that iterative, collaborative conversation, bringing in some non-traditional partners into the mix to deliver capabilities more quickly. Delivering min-viable capabilities, device big bang delivery of capability. All of that, I think, is a function of the imperative to go fast, balance, prioritize schedule over cost and performance, and bring capabilities to our warfighters quickly.
Yeah, and I'll answer that question by way of an example, hypersonics. So hypersonics is something that for so long has been like a white whale, right? It's too exquisite, it's too expensive, it's too far out there, it's too hard. Meanwhile, we have no program of record today in the United States. We have a mass capability gap with our adversaries. So the way we've attacked that problem is, all right, can we do something that's 100% American-made? Can we bring agile manufacturing to bear? And we've done it. And what I can say publicly is we've flown multiple times this year, sustained hypersonic speed. We've proven that you can not only do that, but then proven reuse as well. And we can make hypersonics an affordable, mass precision, cost-effective weapon. Now, is the military, is the Navy, is the Army, is the Air Force, are they comfortable using liquid rocket engines? That's a risk tolerance issue. So we're using that 10 years of knowledge and development and then trying to produce a storable version of it. Storable meaning room temperature liquids that are something that you could easily commoditize that might be sailor or soldier proof or coastie proof or marine proof. That's a different level. But truly, I mean, so hypersonics, I mean, think about it. What's the first thing that comes to all of your mind when you think hypersonics? It's elaborate, it's exquisite, it's too expensive. It doesn't need to be. So we've got several government customers pushing us every day. Can you get that price down? Can we get to mass? Can we do it? And we're going to bring all of that to bear. Ladies and gentlemen, I think we can solve that problem. We can only do it if we work together. It is a very hard problem. I mean, for those who don't know, hypersonic is faster than Mach 5. It is very fast. There's all kinds of things that happen after Mach 5. And if you're Maverick and you bail out, you do incinerate. Sorry, hate to ruin the movie. The point I'm making here is that these hard problems can be solved if we're willing to look at them a little bit differently, and we're proving it to be so. Thank you.
All right, perfect. If anyone would like to line up at the microphone to ask questions, please feel free to do so. While folks are getting their questions together and getting in line, I'm going to just throw out one more. Barbara, early on, you were talking about making investments not only in your first-tier suppliers, but lower down in the supply chain. And I just wonder how you've gotten your arms around getting into that visibility of where the investments need to be made.
Yeah, I mean, that's what's really tough, especially when we talk about going beyond second tier into third, fourth tier level suppliers. It's really sometimes hard to have that visibility. I think, that's where the partnership can help, having the Navy be a voice with many of our suppliers as to understanding why. We also need to make sure that we're clear on, intent. What is the intent of understanding our multiple tiers of our supply base? And that also goes to the concern, I would say, that many of our suppliers have on, data right access, IP access, because for many of our smaller suppliers, it's very different, right? I mean, it's easy for me as an RTX organization. I have heavyweight backing that's very different than many of my suppliers have. But what has really helped us is ensuring that we don't wait for the problem to occur. So typically when we've been in the past talking about lower tier levels in our supply base, we're talking about it when we find out that something failed at our supplier, when there's an acute problem that's stopping production. We need to get ahead of it by working with our first tier suppliers to build that understanding, understand what the true capacity constraints are, and also taking an industry-wide view. One of the other things we're doing at RTX is not just looking at what we're putting in the supply chain, but what our peers are putting into the supply chain, because we have dynamic, fueled by AI, ways of analyzing where is the industrial base going and where are we putting weight onto single sources or two sources that can't bear that burden over the long run. But it's not an easy, Megan, problem to solve, but the real point is don't wait for the problem to occur, and also don't think that all of our suppliers are equipped to solve it in the same ways.
Great, thank you. Oh,
I was going to add, that's probably the biggest hurdle we see working with industry right now, whether it's on procuring a new system or sustaining one of the systems we have, is supply chain visibility and an accurate supply chain risk assessment. As we buy new airframes, I hear from particular big primes often that there's supply chain risk. We can't get people to bid, particularly in multi-years where you look 3-4 years down the road, hard to tell what the economy is going to be doing. What I ask our industry partners, and we work with our industry partners closely, is to help us share that risk, help the government and industry build the right contract where we can share that risk. Because we see it out there. Obviously, we want industry and our partners, the industrial base, to be profitable and healthy. So help us let us share that risk with you. And then in sustainment, we come across all the time, especially on our legacy platforms, where a third, fourth, fifth tier supplier decides they're getting out of the business or whatever it is. The sooner we can know about that using AI, understanding demand versus the resources that are out there and the suppliers out there to identify that, the better we'll be on our sustainment and availability side.
great, thank you. Sir, go ahead.
Yeah, question for Barbara. So I understood you to say you have legacy products that are in large demand, and then you're trying to innovate at the same time. Can you talk a little bit about where you're getting the capacity? I'm Craig Dempsey, Chief Technologist, Naval Nuclear Laboratory, so we have some legacy products too. But things like zero-based budgeting, is it are you able to get money from the corporation? Do you need to have special contracts with the customer to be able to carve out capacity? How are you creating the capacity to service your legacy product line and bring in new product line?
Yeah, so appreciate the question, thank you. So first off, we are innovating into our legacy products as well. So many times we're doing upgrades, capability upgrades to existing products. But relative to how do we get to capacity? So again, I'm very fortunate that being part of RTX, I have a lot of support from my leadership to make investments. So it's a partnership between, I'll use Tomahawk as an example right now without going into specific quantities. We have investments that we are making as Raytheon RTX into the increased capacity. We have investments that the Navy is making into the increased capacity. So it's a blend of multiple colors of money, but what we're really focused on is driving to the detail of what specifically is needed and making sure that we do a risk assessment on do we have single points of failure that we need to invest in. And that's probably one of the hardest parts, and I'm sure others in my peer industry group could understand, is that when we're talking about the legacy products, very old test equipment, at what point do we invest in replacements on some of those aging equipment, especially just given the investment required to modernize. And that's why we're focused on as we modernize, even if it's for a legacy product that's not having a capability upgrade, if we can modernize some of that equipment and get capacity out at the same time, because we're going to automation, less test operators needed, working 3 shifts without the dependency on so many people, it helps. But it's really a blend of investments from multiple sources. But for us, if we have a clear demand signal, which we do for most of my business, we are very well equipped to be able to take, on investments and look at the risk profile of that.
A quick follow-up. Is composability part of that?
Yeah, so composability, I mean, we are focused on the building blocks. So you look at our, I don't know if that's what you mean by composability. That's what we mean by when we talk about composable designs. We intentionally, so you look at our SPY-6 family of radars, we're intentionally building blocks into our design that then can be used for other size radars, other things. Same with our weapons. We have building blocks in our next generation weapons that we could backfit into some of our legacy weapons as well. And that, the more we can do to drive commonality, it helps with securing and assuring our supply base as well. When everybody's doing different things and we have a bunch of snowflakes, it's harder for our supply base too.
Sir, go ahead and please introduce yourself when you ask your question.
Hello, myself Abhi Chopra. I'm the founder and CEO of BQP. We are a dual-use startup accelerating modeling and simulations using quantum computing without quantum computers today. My question is to all 3 panelists, where we're talking about modeling and simulations and digital engineering. Can you point to the trends and the challenges that you are seeing? Is it regarding computing? Is it regarding integrations like systems like MBAC we are talking about? Or is it regarding the solvers being outdated and taking a lot of time? Thank you.
I can start and then I'll let other panelists. I mean, so for one of our challenges is the data. So we need to have the computing capability, but at RTX we've invested a lot in computing capability, but we have to have the input in a manner that is going to be able to be processed. And so ensuring that we have our data organized in a way that is going to enable the use of, digital models, AI, and analysis is something that we're also very focused on, because we can have the tools, but if we're not organized to use the tools effectively, it's hard to implement, and especially because, as brought up, we have a lot of legacy programs.
So I would say systems integration, data analysis, as Barbara said, are certainly challenges we look at. Data security, right? So when we're talking about printed files for printing and so forth, it's all digital engineering, of course, so we're very concerned about security there, especially when you think about when you share that with certain suppliers or vendors and so forth, and of course, customers. So all those problems reign supreme, and you can never have enough, right? I mean, I was an engineer. I wasn't a very good engineer, but I will just say that, we iterate constantly on our systems engineering and integration, so we're always looking for better solutions. Thank you.
Yeah, I think Barbara mentioned data. I think that's probably the biggest hurdle I hear, and I'm not a digital engineering or AI expert by any means, but as we try to start implementing those tools and look for examples where we can pull them in, data seems to be the one hurdle that I keep hearing coming up. We do fly a lot of legacy systems where the data and the models aren't there to support a digital engineering environment or use the AI tools most effectively. We said on E130, C53K, some of the new stuff we're buying in our portfolio, we're looking to leverage those tools. But, and then again, even on our legacy platforms, cleaning that data, building the data, gathering more data so we can use all of the latest tools to help us make better decisions. And I think the other part is the culture. I'll keep coming back to culture. Once we have those tools, once we understand those tools, getting our engineering team, our sustainment team on the government side to be comfortable and use those tools to the maximum possible as a culture change.
Thank you.
Great. Next question, please.
Hello, my name is Aral Soikan. I'm with Fairmont Consulting Group. We're an aerospace and defense-focused consultancy. Thank you all for your time today. My question for you deals in the realm of capacity. One sort of thought that I've had and that I've heard people discuss is when it comes to ramping capacity on, existing or new defense programs, what do you all think about tapping into traditionally non-defense industries? Like I've heard people mention that, there's some like idle automotive manufacturing capacity in the United States. Why doesn't Raytheon or the government try to tap into that? And what sort of barriers do you see to accessing, this non-defense part of American industrial might? And, what are we doing to overcome that?
Yeah, so two barriers, and we've touched on them. One is going to be the qualification side of it, and especially if we're looking at opportunity with a partner, supplier that has not previously worked in the defense space. Requirements are different. They're different for a reason. That's where we feel at RTX we have an opportunity to help guide and support some of the non-traditional partners that we have, but getting to the qualification and an approval of a use of a new vendor, even if the design is approved, there still is a qualification process for the vendor itself. And then the second piece, and Ben mentioned this, is depending on what's being done, the security side of it, and ensuring that we do hard things for a reason, and making sure that we are protecting what is needed to be protected.
Yeah, I think it starts with understanding the demand signal and putting the right demand signal into the system. You can see it in munitions where the demand signal's been pretty clear over the last few years, where industry has been investing in new plants and new capacity on munitions. I think across the board, across the rest of the portfolio, we talk about demand coming if we get into a fight, but it takes an investment now, several years in advance, to build up the workforce, the infrastructure, the tooling to actually manifest that capacity. And without a strong, clear signal and funding to support it in the budget from us, industry struggles to make those investments. The flip side of that, the alternative business model would be someone like an industry partner, not traditional industry partner, investing their own money in capacity, bringing it to us. The trade you make there is if industry makes that investment themselves, we can't demand the IP, the data, the sustainment, organic sustainment that we would like to have. Because they're going to bring us a product, a commercial model, right? Kind of like Apple. They bring you an iPhone. You don't get all the data that comes with it, the sustainment data that comes with it. You buy the product. So that's kind of the two ends of the spectrum. Either we make an investment up front, help industry make the right investment, or we buy what they bring us and we rely on them for sustainment and upgrade. And I don't know there's a right answer. I think that depends on the capability you're talking about and the sustainment model you want to have. But I think both of those are good models.
Thank you. And I think we can get to the one last question if we get a quick question and a quick answer from the panel, please.
Good luck. Bob Arnold Standard. You mentioned getting in deeper levels of the supply chain and getting in front of problems. One oncoming problem is the enforcement of the CMMC concerning CUI. Many of your lower level subs are not in compliance. They are sole source of critical components, and they do not plan on making the investment to get in compliance. How do you handle that challenge?
Well, I think that goes back to partnership. I think that's why we need to understand, because again, I definitely appreciate that it's difficult for the requirements that are flown at the prime level to me. Pushing all those requirements down into each level of the supply chain is very difficult, because what we can be compliant to may not be something that's as easy for one of our suppliers to be compliant to. But it's about transparency in the communication, and then working in partnership with how do we get to a solution, and understanding what is needed. There's some areas where the Navy is not going to be able to waive requirements because they're absolutely needed for a very specific reason, and there's other areas where we can work as partners to find solutions. But happy to chat after the panel as well.
Yeah, and that partnership extends to the government. There's government resources and tools out there to help smaller suppliers as well to get through those CMMC requirements.
Thank you.
Wonderful. Well, thank you so much for the audience for being so attentive and for your questions. Thank you again to Navy League for hosting us today, and for my wonderful panel here, please. Thank you so much. Thank you.